Okay, multiplying and dividing radical expressions. Radical expressions is something, oops, my bad. Radical expressions are going to be something along the lines of this. That's a radical expression. It's an expression, it's got a radical sign. And we know that when you read that, you should be reading the square root of x. If there's no number here in this region, then we know that it is automatically a square root, just like we know that if there is no exponent here, we know that it is a 1. Those are some of our understood things in math. So before multiplying and dividing, we might want to make sure that we can simplify. Simplifying a radical expression is breaking that grouping symbol down into its simplest terms. So as we look at this, simplified radical is making sure that it's all prime. We can do nothing more. So we're going to break this expression down in what is the simplest form. So it is asking us for the cubed root. So the cubed root, I'm looking for the cubed root of 128 and times the cubed root of x to the 7th. Well, let's see. We know that the 128 could be the cubed root of 64 times 2. And we know that the cubed root of x to the 7th could be x to the 2nd times x to the 2nd times x to the 2nd times x. And I'll show you in a second why I decided to break it down that way, but we were looking for sets of 3, something that we can multiply times itself 3 times. And here we know that, further break this down, that the cubed root of 64 times the cubed root of 2 times the cubed root of this stuff right here. We're going to have, what is the cubed root? The cubed root of 64 should be 4 times 4 times 4. There is no perfect cube of 2, and I know that I don't have a perfect cube in here, but I can definitely find some variables that we have cubed. So if I know that this 64 is, the cubed root of 64 is going to be 4, and that will simplify that expression. And I cannot simplify the cubed root of 2 anymore, and simplifying this expression right here, well, I have 3x squareds. Well, 3x squareds, that's the cube. I'm looking for 3 things multiplied together. That allows me to bring one of those x squareds out, getting rid of that, leaving behind still a cubed root of x because I can't find a perfect cube there. So when I take all this and I rewrite it, I should have, I should have 4x squared, and then I am going to have the cubed root of 2x, and there you go. There is the simplified form of that expression. Okay, so let's go on to this next one. Now we are talking about simplifying a product, and I would say that there are multiple ways to do this. Each person is going to have a different way to visualize this, but we know that, let's go ahead and break it up into our squares. Remember, if it's not there, we know that it's a square. And I want to go ahead and begin here by combining this underneath one radical. And what we're going to get here, when I combine it, I'm also going to use some factors. So we know that 45 is 9 times 5. We know that 35 is going to be 5 times 7. And then I know here that when I multiply x to the 5th times x to the 1st, I'm going to get x to the 6th. And also y to the 3rd times y to the 4th, and that's going to give me y to the 7th. So now that I've done some combining, I know that goodness, look in some simple stuff here. 3, what is the square root of 3? Well, we know, I'm sorry, square root of 9. The square root of 9 is going to be 3. So I can go ahead and bring that out outside the radical. And I know here that I have 2 5s, or I have 25, and I know that the square root of 25 is going to give me a 5, so I can go ahead and bring those out. There's nothing I can do to find the perfect square in 7, so let's go ahead and I'm going to rewrite this. So we're going to have 7 times. Now I'm going to go ahead and break those variables up. And since I'm working with squares, remember, I'm going to break that up into x to the third times x to the third and y to the third times y to the third, and then I still have this extra y out here, and that's y to the first. Okay, so let's go ahead and write this out. I got 15, and then looking at the square root, yeah, I know I'm going to have the square root of 7, right? That's still going to be there. There's nothing I can do about that. But now you can see, hopefully, that I have x to the third times x to the third. So those are squares. So I can bring one x to the third out. And I have y to the third times y to the third. And I can bring one of those out. And that leaves behind the single y. And now I can just rewrite that and simplify it. I've brought all the perfect squares out I can. I have 15x to the third, y to the third, square root of 7y. That is the simplest of a product, simplest form of a radical using the products. All right, so let's see here, dividing radical expressions. Let's see, let's go ahead and break this thing up into some factors. So we know that this and this, let's do some simplification here. And if I know the denominator is going to be the square root of 2x to the fourth, well, I know that 50 is 2 times 50. And then I know that x to the sixth could be x to the fourth times x to the second. And now I might be able to do some cancellations, but I'll break it out anyway. Square root of 2, square root of 25, square root of x to the fourth, and the square root of x squared. All of that is going to be over the square root of 2 and the square root of x to the fourth. So what I've done is I've just divided those into their prime factors, or split them up into their prime factors, and now I can cancel values of 1. The square root of 2 over the square root of 2 becomes 1. The square root of x to the fourth over the square root of x to the fourth becomes 1. And now the only thing that I have left is going to be the square root of 25 is 5, and the square root of x squared, remember those are going to cancel out, is going to be x. So there you go. There's the simplest form of the radical dividing. Okay, now we go into rationalizing a denominator. When we talk about rationalizing a denominator, just for some background, we learned very early when dealing with fractions that we couldn't have things like this in a fraction. We couldn't have this portion in a denominator. You know, this was a no-go. And we couldn't have, just for an example, a fraction within a fraction in the denominator. So we also can't have a square root in the denominator because that is not a whole number. That's actually a decimal. So let's look at trying to create something that when we rationalize the denominator, that's what we're trying to do. We're getting the radical out of the denominator in the same fashion that we would get rid of a fraction in the denominator or a decimal. Okay, so I want to, when I'm going to go ahead and work on this radical, and simplifying simplifying rationalize the denominator, I want to find the multiple which simplifies and removes the radical the easiest. So what I'm looking for here, they've asked me to provide you a cube root, right? We're looking for the cube root. So the easiest way for me to do this is I just turn around and I'm going to multiply it by the value of 1, and it's going to be some cube root over another cube root, and of course it will be the same one. And I'm looking at my denominator, and what do I need to know in order, what is 5 cubed? 5 cubed, well, I have 1 5, so if I were to find 5 cubed, I would need 2 more 5. So I'm going to, 25 is 5 times 5, so that's going to give me 5 cubed when I multiply that together. And then I know since I have just 2 y's, I'm going to need to multiply by y to get y cubed. And let's see here, so that's going to be 25 over y. So I'm going to multiply this entire fraction by the value of 1. And what we'll do is we can just go ahead and multiply this out and see what happens. And the denominator becomes the cubed root of 125 y to the third, and the numerator becomes the cubed root of 175 xy. All right, so I have to find the cubes now, and let's see, I know that 125 is going to be a perfect cube, so the cube root of 125, and I guess what I can do is I can go ahead and simplify this one more time. So I have the cubed root of 175 xy over the cubed root of 125 is going to be 5 cubed, and then y cubed, of course, is going to be the cubed root of y cubed. So I end up simplifying this to 175 xy over 5, and then y. And there we go. I have rationalized the denominator. I no longer have a radical in the denominator.